Let's take a look at this example. I'm going to rewrite this problem in the fraction form. So I'm going to have 8.4 times 10 to the 6th over 4 times 10 to negative 7. I have to divide these two numbers first. 8.4 divided by 4 is 2.1 times. Anytime you divide numbers with the same base, you're supposed to keep the base and subtract the exponents. I have 6 minus negative 7. And I have 2.1 times 10. Negative times negative will give me positive. So this is 6 plus 7. 2.1 times 10. 6 plus 7 is equal 13th. 13th is not multiple of 3. So I have to convert this number, this exponent, to multiple of 3. If I'm going to make my exponent smaller, my number is going to get bigger. If I'm going to move my decimal point once to right, this automatically become 12. And I'm going to have 21 times 10 to 12. 12 is multiple of 3, and the number on the left side of decimal point is between 1 and 999. That's why this is the correct answer to my problem. Let's take a look at the second example. I'm going to rewrite this expression in terms of fraction. I have 51 times 10 to negative 7 divided by 17 times 10 to negative 2. 51 divided by 17 is equal to 3 times 10. I have to keep the base. Anytime I divide two numbers with the same base, I have to keep the base and subtract the exponents. I have minus 7 minus negative 2. I have 3 times 10 negative 7. Negative times negative gives me positive. I have 3 times 10 to negative 5. Negative 5 is not multiple of 3. If I'm going to convert negative 5 to negative 6, my exponent will get smaller and number is going to get bigger. I'm going to move my decimal point once to right. That's why I'm going to have 3 times 10 to negative 6. One more time. Anytime exponent is getting smaller, number has to get bigger. Negative 6 is multiple of 3. And the number on the left side of the decimal point is between 1 and 999. That's why this is the correct answer to my problem.